By some estimates, ancient miners pulled more than 1 billion pounds of copper out of the Lake Superior region. They left behind thousands of pits and the stone hammers they used, and almost nothing else. No great cities, no mountains of finished tools, just the holes where the metal used to be. So where did it all go? And who were the people who took it? Along the northern edges of Lake Superior, the Keweenaw Peninsula, Isle Royale, and the shoreline of Upper Michigan form a single, interconnected geological system. Here, tucked within the volcanic rock, lies native copper, a rare, naturally occurring form of pure metallic copper. Unlike the ores of the ancient Mediterranean, this metal required no smelting. Ancient miners could simply hammer it cold, occasionally heating and cooling the metal in a process known as annealing to restore its flexibility before shaping it into tools and ornaments. Archaeologists refer to the people who worked these deposits as the Old Copper Complex, though this remains a modern label rather than a name the miners used for themselves. The physical footprint of their work survives in thousands of shallow pits, depressions, and waste areas scattered across the region, alongside countless stone hammerstones used to shatter the basalt rock. Radiocarbon dating of charcoal from these pits places the mining activity between 6,500 and 3,000 years ago, with some tool dates extending even further back. While these pits confirm that systematic extraction occurred over millennia, they do not provide an exact measure of the total volume removed. How did a seasonal prehistoric population organize the labor required to work these remote deposits? In 1950, geologists John W. Foster and Josiah D. Whitney published a land district report featuring the legendary estimate that ancient miners removed 1.5 billion pounds of copper. Rather than a complete ancient inventory, this figure was a 19th century extrapolation. The surveyors mapped visible surface pits and measured vein dimensions, then applied broad assumptions about uniform copper purity, unsurveyed pit counts, and a steady waste-rock ratio. These early surveys, some researchers point out, carried strong industrial-era incentives to portray the territory as an incredibly rich resource to attract mining investment. Today, the estimate itself is heavily disputed. There is an undeniable contrast between the claimed scale of extraction and the small fraction of copper represented by surviving North American artifacts and burial mound finds. Modern calculations vary widely. Some GIS and LiDAR-based models suggest a much lower estimate of roughly 500 million pounds, while other studies yield different results, meaning no single figure is settled. This clear variance between measured observations and grand inferences raises a fundamental question. If the original numbers were heavily inflated, how much of the mystery actually remains? Or are we still looking for an enormous volume of ancient metal that somehow vanished from the continent? Ancient metalworkers transformed this exceptionally pure native copper through a cyclical physical process of impact and heat. Because the recovered copper was already in metallic form, it required no smelting. Instead, artisans began with cold hammering, striking the raw nuggets with heavy, ungrooved beach cobbles to flatten and shape them. Repeated impact, however, changes the crystalline structure of the metal, causing it to work harden. As the copper became thinner, it grew increasingly brittle and prone to cracking. To overcome this, the miners used annealing, a process of controlled reheating in open-air wood fires, typically reaching several hundred degrees Celsius. This thermal treatment recrystallized the grain structure, restoring ductility and allowing further shaping with grooved hammerstones. Within the bedrock pits, miners applied a similar thermodynamic principle called fire setting. They built hot wood fires directly against the hard basalt host rock, then quenched the surface with cold water. The sudden thermal shock fractured the surrounding stone, allowing workers to pry the copper free. According to archaeometallurgical studies, while fire setting significantly reduced the mechanical effort of stone hammering, the process remained entirely non-smelted, leaving no evidence of a large-scale smelting industry. How did these localized, labor-intensive techniques scale up to feed a regional network? Scattered across the ancient pits, heavy grooved and ungrooved hammerstones, copper debris, fire-cracked stone, and thermally altered ground reveal the locations of prehistoric processing areas. Wear patterns on these stone tools indicate repeated cycles of extraction and metal shaping. On some sites, grooved hammerstones show signs of being hafted with wooden handles, while ungrooved beach cobbles show pitting from direct impact against the hard basalt rock. Some researchers interpret these distinct tools as evidence of an organized division of tasks, suggesting that specialized crews managed the fire setting, others fractured the stone, and finishing artisans shaped the copper. However, archaeologists approach these roles cautiously, viewing them as functional task divisions rather than evidence of a rigid social hierarchy. This framework presents the anonymous miners as highly skilled local communities, directly challenging older myths of a romanticized lost race or the assumption that all workers belonged to one unified nation or centralized kingdom. Ultimately, physical archaeology identifies manufacturing practices and regional material connections much more securely than it can recover names, languages, or political structures. If the soil and stone tools cannot assign a specific ethnic identity to these ancient metalworkers, how did these independent communities organize and sustain the collective labor required to work the mines? To understand how these ancient miners operated, researchers look to Isle Royale, a rugged, isolated wilderness in the cold, volatile waters of Lake Superior. Reaching this remote island required a hazardous open water crossing of at least 15 miles from the northern mainland. Mining on the island was strictly seasonal, heavily constrained by brief windows when workable weather, safe waters, and accessible ground all met. According to archaeological surveys along the island's Minong Ridge, thousands of prehistoric pit mines show where generations of workers returned to the exact same copper veins over thousands of years. Near these trenches, researchers have mapped ancient hearths, charcoal lenses, animal remains, and stone-lined storage pits. Some researchers argue these temporary occupation features indicate that crews stayed near the workings for extended periods rather than conducting rapid, single extraction runs. Getting to the island and transporting the heavy metal back required dependable watercraft, likely birch bark canoes or large dugout vessels, though direct physical evidence of these boats remains scarce. While these water crossings were clearly viable, others point out that they raise questions about the scale of coordination required to keep these remote camps running. How did these seasonal crews manage to feed, fuel, and organize their workforce in such an unforgiving environment? Extracting copper required an extraordinary investment of physical effort. Experimental archaeology indicates that producing just a single pound of finished copper demanded 10 to 12 hours of intense labor, combining fire setting, hammering, and annealing. To estimate the workforce behind this effort, researchers rely on mathematical models of pit volumes and experimental productivity instead of written records. These models suggest that even a modest operation would require dozens of miners to extract a few dozen pounds of copper per day. Sustaining these seasonal crews for 2 to 3 months on Isle Royale required a complex supply chain of food, wood fuel, containers, and shelters. Some archaeologists propose this was managed through cooperative, household-based networks, where extended families pooled resources. Others argue that larger expeditions were coordinated by influential leaders, though researchers emphasize this implies localized coordination rather than a centralized state authority. Experimental specialists point out that transporting these supplies, and the heavy metal itself depended on watercraft like birch bark canoes, which could carry hundreds of pounds of cargo per trip. This leaves us to consider who stayed on the mainland to provision these distant miners, and who ultimately controlled the distribution of the finished metal. Who managed to keep these scattered crews returning to the islands season after season, and how did they begin moving this heavy material far from its geological source? To track the destination of this ancient metal, mainstream archaeologists point to a widespread domestic trade network that spanned the continent. Thousands of native copper artifacts, including spear points, knives, bracelets, and elaborate sheet metal ornaments, have been recovered from archaeological sites stretching thousands of miles from Lake Superior. Many of these items emerge from the earthworks of the Hopewell Interaction Sphere in the Ohio River Valley, as well as later Mississippian centers like Cahokia and Moundville. Researchers emphasize that these complex mound-building societies operated much later than the earliest archaic mining periods, indicating that copper remained in circulation or was continually salvaged over millennia. Geochemical provenance studies, using trace element and lead isotope fingerprinting, confirm this continental connection. According to these analyses, more than 80% of the copper artifacts recovered from Ohio Valley mounds trace directly back to the Lake Superior Basin. The metal likely moved along river highways via canoe and overland trails, circulating as finished tools, raw nuggets, or thin sheets. Yet the total mass of these recovered artifacts represents only a tiny fraction of even the most conservative extraction estimates. Some archaeologists argue this discrepancy is not a mystery of missing cargo, but a natural result of how the metal was used. Over thousands of years, copper was repeatedly hammered, worn down, lost, or intentionally recycled into new forms, a process that erases the physical record of its original volume. From this perspective, the surviving mound artifacts represent only a small, preserved sample of a material that was constantly spread thin and reclaimed across generations. But is this domestic dispersal and recycling enough to explain the sheer scale of the vanished metal, or did some of it travel even further? Some researchers argue that a portion of the Great Lakes copper may have traveled far beyond the Americas, pointing to a trans-oceanic hypothesis. Popular accounts often focus on the Uluburun shipwreck, a late Bronze Age vessel discovered off Turkey and dated to approximately 1300 BCE. The wreck carried about 10 tons of raw copper ingots. Proponents of an international connection claim that chemical tests show an isotopic overlap between some Mediterranean ingots and the native copper of Michigan. Mainstream archaeologists point out significant problems with this interpretation. Geochemists note that lead isotope fields are broad, and many ore districts around the world share similar chemical signatures, meaning an overlap is not a definitive shipping record. In addition, the timeline presents a major challenge. The peak of intensive mining in the Lake Superior Basin occurred thousands of years before the Uluburun ship sailed. There is also a complete lack of associated material culture. No Mediterranean artifacts have been recovered in the Great Lakes, and no North American tools exist in Bronze Age ruins. To most historians, the Uluburun wreck demonstrates the reach of Bronze Age trade within the Old World, rather than a proven connection to North America. It highlights the distinction between what is possible and what the physical evidence actually proves. Does the surviving data justify the theory of an ancient global trade route? Or does the evidence stop short of proving such a connection? Subscribe for more historical investigations, and let us know in the comments if you think the copper was traded away at home or carried across an ocean. Long before European geologists mapped the shoreline, the Ojibwe and other Great Lakes nations maintained their own relationship with the region's mineral resources. Their oral traditions preserve references to copper places, or Michigami, and the people associated with the metal. Tribal historians and cultural authorities explain that these accounts represent living cultural knowledge and continuity rather than literal archaeological reports. Anthropologists point out that these histories are not automatic proof of the ancient miners' identities, specific trade routes, or transoceanic crossings. Researchers also caution against directly equating the prehistoric Old Copper Complex with historically documented Ojibwe identity or any single modern nation. Instead, the memories offer a parallel, culturally rich perspective on the territory. This is reflected in later historical accounts, such as those recorded by 19th-century observers, describing Great Lakes people carrying small pieces of native copper as sacred items of protection and power. Rather than serving as eyewitness testimony of Bronze Age mining, what the elders remembered remains a reflection of the enduring spiritual and cultural significance of the metal, preserved across generations through spoken word and sacred geography. Over thousands of years, native copper was repeatedly cold-hammered, heated, and reshaped. Some researchers argue this continuous reworking preserved the physical metal while systematically erasing its original form, archaeological context, and line of ownership. Because recycling rates for the earliest archaic periods remain poorly quantified, tracking the exact flow of metal is exceptionally difficult. This material reality forces a distinction between secure evidence and broad inference. The physical trace of ancient extraction, highly skilled metalworking, and circulation beyond the Great Lakes is well established. Yet the exact volume of copper removed, the identities of the miners, their organizational structures, and the ultimate fate of the metal remain unresolved. In this context, the estimate of £1.5 billion is best understood as a disputed assumption. If the original 19th century calculations were heavily inflated, the apparent gap of missing copper shrinks, though the surviving artifact record still fails to match even conservative modern extraction models. When metal has been lost, reshaped, and scattered over millennia, how much of the original story can ever be recovered? Subscribe to the channel and let us know in the comments. Do you think this copper stayed within domestic indigenous trade networks, or did some of it cross an ocean? Today, the ancient pits of Lake Superior remain silent. As science advances, we continue to weigh disputed estimates against a shifting physical record. The ultimate question is not just where the metal went. It is how we choose to interpret the quiet spaces of our history. Until the Earth yields more clues, the copper remains an enduring mystery.